This is Algebra Lesson 8-3, the multiplication property of exponents. By the time you're done with Chapter 8, you'll have a lot of properties of exponents. You might find it helpful at the end of this chapter to write all the properties on the same piece of paper so that you can look at them all at the same time. It doesn't really matter, you just need to learn the properties. Let's look at something here. We're going to find a pattern. If I have 8 to the third times 8 to the second, that is the same exact thing as saying 8 times 8 times 8 multiplied by 8 times 8. Now, if I had to multiply those out longhand, that may take me a long time, but that's not what I'm looking for. I have a lot of 8s here. In fact, I have 5 of them, 3 and 2. This is the same thing as saying 8 to the 5th, because there are 5 8s. If I look at with variables, I have c to the third times c to the 8th. That's going to be c times c times c, multiplied by c times 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 c. I have lots and lots of little c's. Right? So if I look at this, I have 8 of them and 3 of them, and 8 and 3 is 11. So this becomes c to the 11th. Now, if we look back at our original problem here, if we carefully look at our exponents, we have 3 and 2. If we add 3 and 2, we get 5. On the second problem, we have 3 and 8. If we add 8 and 3, we get 11. So this leads us to what we call the multiplication property of exponents, which means that the sum of the exponents of the expression equals the exponent of the answer. Put in mathematical terms, for every non-zero number, a, and integers m and n, a to the m times a to the n is the same thing as saying a to the m plus n. In other words, if I'm going to multiply numbers with the same base, see they have the same base a, if I have a number taken to an exponent, the same base number taken to a different exponent, or the same exponent, I'm just going to add the exponents. Here's an example. 5 to the third times 5 to the fifth is the same as saying 5 to the 3 plus 5, or 5 to the 8th power. It only works if you have the same base. That is absolutely critical. That's why it's called multiplying powers with the same base. That same base is absolutely critical. If you don't have the same base, you can't add the exponents. So, let's look at some things here. We're going to rewrite each expression using each base only once. And if we can simplify it really far, we will. But if it simplifies to a number that's way too big, we won't. For example, if I have 2 to the third times 2 to the 6th, these have the same base, the base of 2, so this becomes 2 to the 3 plus 6. You don't multiply the bases together. No, it doesn't become 4 to something. It's still 2. You take that base, 2, to the power of 3 plus 6, which becomes 2 to the 9th power. 2 to the 9th power, even though it's not a super huge number, you can multiply that out or use your calculator to figure that out. It only adds up, multiplies out to be 512. If your numbers are fairly small, you should multiply them all the way out, okay? If it's asking you to simplify. But in this case, it's not asking us to simplify, it's just asking us to rewrite each number using each base only once. So we don't need to do this, we need to do this. That's why it's really important to read your directions. If it said to simplify, we would go all the way to 512, but it didn't ask us to simplify, so we wouldn't. Number 2 says a to the 4th times a to the 7th. All of these have the same base of a, so this would become a to the 4 plus 7, which is a to the 11th power. Somebody's going to ask me, do we have to show this middle step right here? No, not necessarily. If you get the answers wrong, then yes, I'll start asking you to write that little step in there. But most of you can probably do that middle step in your head. Some of you may need to do that middle step for a little while until it becomes second nature. If we look at problem number 3, we have z to the third, and z to the fifth. Remember, whenever a number or a variable is just written all by itself, it is taken to a power. It's to the first power. Because we already know it can't be to the 0 power, because anything to the 0 power is 1. We learned that in lesson 8.1. So this z here is the same thing as saying z to the first power. So we have z to the first power times z to the third power times z to the fifth power. So this becomes z to the 1 plus 3 plus 5, so it's z to the 9th power. I like to cross my z's so they don't look like my 2's, because my 2's and my z's tend to look a lot alike. We look at problem number 4. Problem number 4 is a bit more complicated. We have x to the second, y to the third, and we're going to multiply that by x to the fourth, y to the fifth. You can only combine the same bases. So I can only combine x's with x's, and then I can only combine y's with y's. So here I'm going to do that. I have x to the 2 plus 4, and then I have y to the 3 plus 5. Since the x's have the same base, I can only equate those exponents, and the y's have their same base, I can only equate their exponents. So I get x to the 6, y to the 8. Problem number 5 here. I have 2 to the 4th times 2 to the 3rd. So since they have the same base, I'm going to have 2 to the 4 plus a negative 3, which is going to become 2 to the first power, or just 2. Anything to the first power is the same thing as saying just that number itself. So either one of those answers would be acceptable. Okay. Moving on, now we're going to simplify. When you simplify, remember, in simplification, all exponents must be positive. So if you get a negative exponent, you have to apply that first property of exponents that we learned about, was the negative exponent property, which was anything to a negative exponent is the same as saying 1 over that number to a positive exponent. So remember that, because that's important. So here, and if you can multiply things out, you need to multiply them out as far as you can go. That's what the difference between simplifying and just writing it as one base. So number 6 here, we have p to the 2 plus 4 plus 1. Don't forget that's p to the first power. So that becomes p to the 7th power. We're done. Can't do anything more with that. Here, we have 2q times 3p to the 3rd times 4q to the 4th. Now, 2, 3, and 4 are just regular numbers, so we would just multiply those like normal, just like that. Then I look at my p's. I only have p to the 3rd. I don't have any other p's. Then I have q to the 1, that will be here, plus 4. So all I have done is equated all my numbers together, because numbers aren't to a power, so these particular numbers are not to a power. So I'm just going to multiply them like normal. And then I'm going to take my variables and make sure that I add my exponents, because I'm multiplying, and if you multiply something, you add the exponents. So 2 times 3 is 6, 6 times 4 is 24, so this becomes 24, p to the 3rd, q to the 5th. And that's as far as I can go with this number, since I have no idea what the p's and the q's stand for. If I knew what they were, later on I could figure that out. Let's look at number 8 here. 4x to the 5th times 3x to the negative 2nd. I have numbers. They're not taken to an exponent other than 1, but they're not the same base, so I can just multiply them together like normal. Okay, they're not taken to a power, so I just multiply them together like normal. Then I have x to the 5 plus negative 2. So 4 times 3 is 12, x to the 3rd. And I'm done at that point in time. Number 9 here can get a bit complicated. So I've got all kinds of numbers, and I've got some negative numbers, and I've got some exponents, and I've got some negative exponents. So I'm just going to look at my numbers. I have a negative 2 times a negative 3 times a negative 5. I can equate all that together. I have a w to the negative 2 plus 2. Those are the only, there's my w's. Then I have b's here. I have a b to the 2nd and a b to the negative 3rd. So that gives me b to the 2 plus negative 3. Now I'm going to multiply everything together and add everything together that I can. Negative 2 times negative 3 is positive 6. Positive 6 times negative 5 is negative 30. W to the 0. B to the negative 1st. Hopefully you remember that anything to the 0 power is 1. And I have a negative exponent, and I need a positive exponent, because remember what I said, when you're simplifying things, they need to be given all in positive exponents, because something's not simplified unless it is to a positive exponent. So this becomes negative 30 times 1 is negative 30. The b to the negative 1st has to go down here to become b to the 1st, or just b. Okay, because I essentially have here, I have negative 30 times 1 over b to the 1st power. So this would be rewritten as negative 30 over b, just like this. Now, in lesson 8-2, we learned all about scientific notation. And we learned that we could use patterns to move your decimal points. Now we can go a little bit further. We can use the properties of exponents for multiplying powers with the same base to write numbers and to multiply numbers in scientific notation. Before, we only had a number, a constant number, multiplied by a power of 10. Now we have a power of 10 multiplied by a power of 10. When you have two powers of 10 that are multiplied together, or more than two powers of 10, you equate the whole number parts, or the non-power of 10 parts, and then you equate the power of 10 parts. Okay, so essentially what I'm going to do is I'm going to multiply what I've drawn arrows to in green, my constant terms, and then I'm going to multiply my power of 10 terms. So I'm going to multiply 2.5 times 6, and then I'm going to have 10 to the 8th times 10 to the 3rd, because those are the things that are paired together. So 2.5 times 6 is 15, times 10 to the 8 plus 3 is 11. But it says I need to give my answer in scientific notation, and that is not scientific notation. It's close, but it's not scientific notation. So what I do know, the easiest way to do this, I do know this. I know that 15 is 1.5 times 10 to the 1st, and I already had it times 10 to the 11 right here. This number goes straight to this, 1.5 times 10 to the 1st, and 10 to the 11th still tags on. So this becomes 1.5 times 10 to the 12th, because of the same base, you add the exponents. So 1.5 times 10 to the 12th is the final answer, written in scientific notation. The next problem, again, equate your constant terms, so 1.5 and the 3, and equate your power of 10s, 10 to the negative 2nd and 10 to the positive 4th, and work with that. So I have 1.5 times 3, which is, and if you remember, it's just like saying 15 times 3 is 4.5. Okay? 4.5 times 10 to the negative 2 plus 4. Okay, so I have 4.5 times 10 to the 2nd. And then we check and make sure it's in scientific notation, which it is. So I am done at that point in time. And our last problem here. 3 times 10 to the negative 7th times 7 times 10 to the negative 5th. Again, equate constant terms, so 3 times 7. Equate powers of 10, 10 to the negative 7th times 10 to the negative 5th. So 3 times 7 is 21, times 10 to the negative 7 plus negative 5 is negative 12. But this is not in scientific notation yet. So this number written in scientific notation would be 2.1 times 10 to the 1st, and I already have it times 10 to the negative 12. So this becomes 2.1 times 10 to the 1 plus negative 12, which gives me negative 11. And that's how to convert things to scientific notation. And not complicated, but important.